Today is third Wednesday, March 11th, 2015. This is Algebra 2. We're on lesson 6-3, page 301, solving quadratic equations using factoring, everybody's favorite word. So this is where that section in chapter 5 was so important. Okay? Instead of just looking at the graph and looking and counting squares to figure out where your solution is, you can why do I keep saying that? But you can factor and use your two sets of parentheses to find the solutions. Now, of course, you always want to check, right? Checking is always a good thing. So, the objectives, of course, solve quadratic equations by factoring, and the second one is write an quadratic equation with given roots. Ooh. So that's going backwards. All right. I want to see why we use this or how. The length of a rectangle is 5 inches more than its width, and the area of a rectangle is 24 square inches. To find the dimensions of the rectangle, you need to solve a quadratic equation where I would have used W because W makes more sense for width. Because how do you find the area of a rectangle? Who remembers? Right, it's just length times width. So this is why they say x times open paren x plus 5 equals 24. X representing the width and x plus 5 representing the the length, which is equivalent to this area of 24. And then you distribute and get x squared plus 5x equals 24. Okay? That's one way to do it. And I bet you that the word problem example is going to be that. Alrighty. This is one of my favorite things because solving by factoring is much simpler in my opinion. But there's also 3 more ways to do this. Let's start with in my opinion, the easiest way. Alright, in the last lesson, most of you learned to solve a quadratic equation like the one shown above, one above by graphing. Another way to solve it is the equation is by factoring. Consider 7 times 0 equals 0. That's true, I hope, right? Well, 6 minus 6 equals 0. Okay. And then, and then 0 times negative 2 equals 0, and negative 4, open paren, minus 5 plus 5 equals 0. They're modeling something with numbers that you're about to see here. Okay? Everything times 0 is always 0. Always, always, always. Okay? Notice that in each case, at least one of the factors is 0. Okay, that's fine. These examples illustrate that zero product property. Oh, well, yeah. I mean, this is important to know why we can factor. Okay? So we'll just go over it real quick in the key concepts box. For any real number, a and b, if a times b equals 0, then either a equals 0, b equals 0, or both a and b equals 0. Well, that makes sense, right? If you ever have something equal to 0 that you're multiplying, one, the other, or both have to be 0. Because the only time you ever get 0 when multiplying is if you multiply by 0. Okay? And then they give you another example. So this is what factoring looks like. If x plus 5, open paren, x plus 5, close, open, x minus 7 equals 0, then x plus 5 equals 0, and / or x minus 7 equals 0. Now remember, y is 0 when we're solving for our solutions. That's why this works along with the zero product rule. So just to give you a preview, if you solved each of these little things, you would get your x solution. And that they might not be true because remember we can have 1, 0, or no solution, or 2 solutions. So when we get solutions by factoring, we got to check in case it's one of those parabolas that has fake solutions. Okay. Here we go. Example 1. 2 roots. See, here we go. It's going to give us an example of all the roots. All right. Solve each equation by factoring. X squared equals 6x. Do we have to do some housekeeping? Yeah. Because remember, when you find the solutions of these, you have to set it equal to 0. Okay. So that's why when you have x squared equals 6x, you need to rewrite it as x squared minus 6x equals 0. Well, let's factor. Does anybody see a common factor we can pull? What does x squared and minus 6x have in common? Yeah, they have x in common. So let's just pull out an x. X out of x squared, that's just x, and x out of negative 6x leaves you with negative 6. Okay. So you can rewrite this little equation as x, because we pulled it out, open paren, x minus 6 close, equals 0. Because we're just pulling out our common factor. So when you have it in the simplest factory form that you can, in this case this is as simple as it gets, you set each part equal to 0, because the zero product rule says, hey, one factor has to be 0, the other one or both one equal to 0. So we say x equals 0 or x minus 6 equals 0. So therefore, to solve for x in the right hand, we already have x equals 0, so we don't have to do anything else with that one. We need to get x all by itself, so we have to add 6 to both sides, and we get x equals 6. So the solution set, therefore, would be open brace 0, 6, close brace. Remember, we talked a little bit about interval notation and stuff like that. Okay. Brace just stands for set. That's why they say solution set. You put your little squiggly bracket, a 0, and then a comma, and then a 6, and then close your squiggly bracket. And in Braille, that's the brace symbol, which is the 4/6 parenthesis, I believe. I always get the bracket and the break mixed up. All right. Well, we got to check these. What happens when we plug 0 into x squared equals 6x? Does 0 squared equal 6 times 0? Yeah. What happens if we plug 6? Does 6 squared equals 6 times 6? Yeah. So we say this particular equation has 2 solutions. Now before I move on, does everybody understand the concept of why we can do this? Yeah? Okay. And everybody remember factoring? What kind of method did I use to factor? What do we call that factoring method? Because we're going to use all types. Okay. Do you remember, Miss Chris?
What method?
What factoring method is that? No? None of you? No?
Reverse distribution.
Yeah, but what's the word for that? Or letters, maybe. Does that help? Letters? Starts with a G. Come on. G. C.
GCF.
Oh, phew. Oh, that was the GCF method. You take out the greatest common factor. Okay. The next one, on the next page, oh, it's part B. So part B is a whole parabola, or excuse me, whole quadratic. Okay. This is one of those ones that I made you guys do over and over again. It's a grouping one. Oh no! Okay. So B says it's at the top of the next page. It's 302.
So is this a grouping method?
Yeah. Oops, I shouldn't have told you. I should have asked you. Oh well. 2x squared plus 7x equals 15. Do we need to do housekeeping? Yeah. So 2x, and they squared plus 7x, and to get rid of positive 15 is negative 15, equals 0. Now, they didn't do a grouping method, but you can, because you could keep all this in your head, right? What multiplies to be negative 30 and adds up to be positive 7. Right, this is the AC method too. Okay. What multiplies to be negative 30 and adds up to be 7? Anyway. Yeah, you're right. Okay.
And a negative.
Yeah, you're right. Negative 3 times 10 will give you negative 30. So you would have to rewrite, because they skipped this step, okay? You would have to rewrite it as 2x squared plus 10x minus 3x plus 15, okay? So to save time, I won't go through all of that with you. Suffice it to say, when they're done, they get open paren 2x minus 3 close open x plus 5 equals 0. It's in part B.
Yeah, I know.
They skipped the grouping step. They just did it for you. Yeah. I was just reminding you of how to do it because, it's been like a week and a half, 2 weeks. Okay. So when you come across these, whenever there's a coefficient in front of the x squared term, you're probably going to have to group. Okay? Because it's harder to think of what multiplies to be negative 30 and adds up to be 7 with the factors of 15 and a 2 up front. That's 4 things you got to keep track of in your head. That's why I encourage all of you to group it first. Okay? But they just did it for you. I don't know why. They're just like, you're factoring geniuses now. You don't need to know how to do it. All right? I think they care more about finding the zeros. So once you have those 2 sets of parens, what do we do? Define the zero/solution/roots of the equation. The new thing that we learned today. Huh? No, we don't have to in this one. We already have it set up into something multiplied by something else. We set up each part equal to 0. Remember before, we had x and then another paren. We set the x equal to 0 and we set the paren equal to 0. Okay. This time we set both sets of parens equal to 0 and see what we come out with. Okay? And you solve them separately. Because again, it's because of the zero product rule. Because when you multiply by something to get 0, one of those factors has to be 0 as well. Okay? One or both. So 2x minus 3 equals 0, or x plus 5 equals 0. So if we use our pre-algebra skills and solve these, 2x minus 3 equals 0 gives you 2x equals 3, and x equals 3 halves when you divide by 2. So one solution may be 3 halves. Okay. Then you do your other little equation, x plus 5 equals 0. Well, to get rid of a positive 5, we've got to subtract. So x can also equal negative 5. And it didn't check because I don't understand when this book does this. Why does it check for one and decide that it's not worth it for the rest? Okay. So we'll just take the book on faith and say that the solution set is negative 5, 3 halves in braces. I mean, you could 3 halves squared times 2 plus 7 times 3 halves, so on. Okay. So let me verbally run through the process one more time. If you have something, ax squared plus bx plus c equals 0, find a way to factor it, either using the GCF method, the AC method, what multiplies to be c and adds up to be b, or by grouping. And you use that when you have a coefficient in front of the x squared term. Okay? When you have it factored into 2 sets of parentheses, or in something that kind of looks like distribution, set up both parts equal to 0. Once you have both sets of parens equals to 0, solve each one separately, and those will be your solutions. Okay? Does that make sense? Better make sense. We're going to do it again. Double root. Example 2. Double. Okay. Solve x squared minus 16x plus 64. Huh, equals 0. Who can factor this right now? Without looking. Don't look. X squared minus 16x plus 64. This is a good one. Yep, because what multiplies to be 64 and adds up to be negative 16 is x minus 8. And x minus 8, because 8 times, or negative 8 times negative 8 is positive 64, and negative 8 plus negative 8 gives you your middle term of negative 16. And so you get, if you have two of the same thing, you have x equals, or x minus 8 equals 0 and x minus 8 equals 0, then you get x equals 8 and x equals 8. That's a little bit repetitive, don't you think? You don't need to write 8 comma 8, okay? If 8's the solution, it can't be its solution twice. It'd be like saying you could be in the same place twice. Like, I'm in the same place, and I'm also in the same place. That doesn't make any sense. So that's why when you get a double root like this, you only need to put it in there once. Otherwise, it's like being repetitive. Oh, look, they checked this one. Except they used the graph. They used the graphing calculator, which I think would be awesome. That would be awesome. Looks like the solution in the little picture is the vertex. So if you get a double root, it's most likely your vertex. Right? Which, by the way, I would like to do some graphing if we can with the graphing calculator. Anyway, example 3. General common factor. Alright, it's a multiple choice test thing. What is the positive solution of the equation? 3x squared minus 3x minus 60 equals 0. Now, if I saw this on the test, I might not do it the way I was taught above. What would you guys do? What?
Take out the simplify it.
Well, if it were me, I've only got 4 choices. I just plug them in, right? You can also factor out a 3 to make your life easier. Yeah. Because all 3 terms have a 3 in it. 3x squared, a 3, and that's minus 60. And then plug them all in. Because if you think about it, would it take you longer to factor and group? Or would it take you, how long would it take you to plug all these in? Right? So it just depends on how you are as a thinker. Okay? The book wants you to factor. But I mean, whatever. It's up to you. It's your test, okay? But what we can do is pull out a 3. Okay? 3 out of 3x squared is x squared. 3 out of minus 3x is minus x. And 3 out of negative 60 is minus 20 equals 0. So now we have open paren 3, or 3 open paren x squared minus x minus 1 equals 0. They got rid of the 3. Can anyone explain why they thought they could get rid of the 3? Why can they do that? It doesn't just disappear. It's not magic. What allows them to do that? It looks like magic, doesn't it? It's not. Think about algebra and what we can do. What can we do? What happens if we were to try to get rid of it? What would you have to do to get rid of a multiply by 3? Because it's outside of parentheses, so we can do that. Right, I want 0 divided by 3. 0. So it's gone, right? Magic! But it's not really magic. Right, so they got rid of it, and that actually makes your life a little bit easier. It's just gone, right? You can do that because it's outside of a set of parens. So when you divide the whole thing on the left by 3, right, the 3's cancel, and 0 divided by 3 is 0. Okay? So now, what multiplies to be negative 20 and adds up to be negative 1? Don't cheat. So again, in factoring land, whatever multiplies to be the C term and adds up to be the middle term. Okay. Well, it multiplies to be negative 20 and adds up to be negative 1. 4 and negative 5, right. So then you open up your two sets of parentheses and say, open paren, x plus 4 close, open paren, x minus 5 close, equals 0. Okay. We have two sets of parens. What should that lead you to do? Based on the new thing we learned today. Right. Excuse me. Set them both sets equal each to 0. As Ella said, better than me. So x plus 4 equals 0, and x minus 5 equals 0. So our options are x equals negative 4 or x equals 5. Okay. Remember, it wanted the positive solution. So we want letter C. Okay? How does everybody feel about this so far? Good? Good. Okay. Because we're on to the last example already. Oh my goodness. Okay, well, I'm at the top of the 303. 303, write quadratic equation. Alright. You have seen that a quadratic equation is of the form, and they just like p's and q's, x minus p and x minus q equals 0, has root p and q, has roots p and q. So remember, roots are the same thing as solutions slash zeros. Okay. You can use this pattern to find a quadratic equation for a given pair of roots. Right, by foiling. Okay. So I'm looking at example 4. Write an equation given its roots. Well, it's given roots, but whatever. Write a quadratic equation with, they had to give us a fraction, 1/2 and negative 5 as its roots. Write the quadratic equation in the form ax squared plus bx equals c, or plus c equals 0, where a, b, and c are integers. So mean. Okay. Okay. So we know that x minus p and x minus q are roots. So how would we put these in parentheses? What do you think? Okay. P and q are the roots, not minus p and minus q. So we're going to flip the signs. Right? Think about this. We always set them equal to 0. X minus 5 equals 0. Right? That meant x was 5. Okay? So your roots are the opposite of what are in your sets of parentheses. Okay? So we would set this up as, since 1/2 is positive, we would say open paren x minus 1/2 close. Open another paren and say the opposite of negative 5 is plus 5, so x plus 5 closed. Okay? X minus 1/2 close, open, x plus 5 equals 0. Okay? And that second line there, they did negative 5. But it's up to you. If you want to plug it all in and say x minus 1/2 and x minus negative 5 and start from there, that's fine. Okay? So then we have to FOIL it, right? Because it's not in ax squared plus bx plus c form, but we know how to get it that way. We use our FOIL method because we have two sets of parentheses multiplying each other that have a binomial in them. I'm trying to use all my math vocab words for you. Okay. Binomial. X times x. Okay. 5 times x. Minus 1/2 times x. That's the intercept. What's negative 1/2 times x? Josiah, want to help me out here? Negative 1/2 times x. Yep, thank you. And negative 1/2 times 5. The last. Negative 1/2 times 5.
Oh, 1/2 times.
Right, or negative 5/2. Leave it in fraction form. You'll understand why in a minute. Okay. So then you would have x squared minus 5x plus 1, or excuse me, minus 1/2 x plus, excuse me, I keep saying plus, minus 5/2. Okay? So then we have to do minus 1/2 x and combine it with the minus, or plus 5x. Okay? Now, we can't because minus 1/2 and 5 aren't in common denominator form, but there are 10 halves in 5, right? So 10 halves plus a negative 5, or negative 1/2 is 9 halves. Okay. So you get, when you combine all the like terms, you get x squared plus 9 halves x minus 5 halves equals 0. Now remember, they wanted to get this equation without fractions in it. Okay? So how can we get rid of these stupid over 2's? What can we do? Yeah, multiply everything by 2 so that they cancel. Okay? X squared times 2, 2x squared. 9 halves times 2, 9x anyway. Negative 5 halves times 2, which is negative 10 over 2, which is negative 5. And then, of course, remember, even though it seems trivial, okay, we have to multiply by the other side of the equal sign. 0 times 2, 0. Okay? So I don't want you guys to get in the habit of forgetting that whatever you do to one side, you have to do to the other. Even though it doesn't matter, like 0 times 0, but just keep it in your mind that you can't, that whatever you do to one side of the equation, because it would be a bad habit if you forgot to do it to the other side when there actually was something important on the other side. Okay? All right, so we finally have it. A quadratic equation with roots 1/2 and negative 5 with integer solution, or integers, is 2x squared plus 9x plus 5 equals 0. You can check this result by graphing on your calculadora. Okay? Solve each quadratic by factoring. Yay! All right. 1 through 13. I like it because one of them is multiple choice. I want to see which method you guys choose to use. 1 through 13 on page 303. Okay. That is the practice we're doing today. I'm going to stop the recording so it can start processing.